Use property 1 of radicals to simplify the following radical expression as much as possible. Assume all variables represent positive numbers. Okay, so remember, if we have something like this, we can rewrite this. It's a cube root. We can rewrite this as 16x to the 7th y squared raised to the 1/3 power. Remember our properties. So if we take this, if you have exponents raised to an exponent, you multiply. So this then becomes, so it'd be 1/3 times this would be 16 to the 1/3, x to the 7/3, and y to the 2/3. Multiply that out there. Well, 16 to the 1/3, probably the easiest way to do these, you have numbers, just take 16. Let's just break this down. That's 2 times 8, which is 2 times 4, which is 2 times 2. So 16 is the same thing as 1, 2, 3, 4. 16 is 2 to the 4th power. That's raised to the 1/3. X to the 7/3, just carry this other stuff down to the 2/3. Okay, we have an exponent raised to an exponent, so you multiply. So this becomes 2 to the 4/3, x to the 7/3, y to the 2/3. And what I'm doing here is I'm showing you the long, I'm showing you every step. I'll do another example here just a little bit later to show you how you can quickly go through these. Okay, so now you look at this, well, 4 divided by 3. What is that? So let's say take 4 divided by 3. Well, 3 goes into 4 one time. 4 minus 3 is 1, so we have a remainder of 1. So we have 1 and 1/3. So 3 goes into 4 1 and 1/3 times. So we can come back over here, so we have 1. So this becomes, we can pull out the 2. The 2 becomes 2 to the 1 and 2 to the 1/3. And then this becomes x, well, to the 7/3. So 7 divided by 3, 3 goes into 7 2 times. 2 times 3 is 6 with 1 remaining. So we have 2 and 1/3. So we have 2 3's will go into there. So this becomes, this is 3, this becomes 2 squared, so this would be x squared with 1/3 left over, so x to the 1/3. And then 3 goes into 2, well, it doesn't go in there equally at all, so this still becomes y to the 2/3, because we can't pull anything out of there. So what we can pull out now, we have 2 to the 1st power, we can pull out 2 to the 3rd, and anything with the 3rd here, we know it's still the cube root, so the 2 has to stay under, x squared, x to the 1/3, so this would be x to the 1 here, because you notice it's 1/3, it's x to the 1st, or 2 to the 1st, and then y squared, and then to the 1/3 power is right there. So the solution here is 2x squared times the cube root of 2xy squared. There's our solution. Okay, so let's just do another problem here, another example. Let's slide this up. Rather than do a new problem, let's just go ahead and do the same problem again, and just I'll show you how to quickly do this without going through the long method there. Well, we know this is the cube root of 16 is 2 to the 4th, which we just figured out a little bit of x to the 7th y squared. Okay, so now we can look at this and say 3 goes into 4 how many times? Goes into there 1 time. So we know the 2 comes out, 2 to the 1st, with how many are remaining? Put this over here, we can have the cube root. Well, there's, see, we said 4 divided by 3. 3 goes into 1 time with 1 remaining, so we know 1, 2 has to stay underneath. 3 goes into 7 2 times, so x squared comes out. And 2 times 3 is 6, so there's 1 remaining, so it becomes x to the 1st stays underneath. 3 goes into 2, it doesn't go in there at all, and so we can't pull anything else, so this stays y squared. And that's how you can quickly do the problem we just did above. Let's go ahead and we'll do another example here for you. How about if we say we want the cube root of 320 x to the 9th, y to the 8th, z to the 4th. Well, 320, okay, let's break that down. So 320 breaks down into 2 times 160, 2 times 80, 2 times 40, 2 times 20, 2 times 10, and 2 times 5. So this is now the cube root of 2 to the 1, 2, 3, 4, 5, 6. 2 to the 6th times 5, x to the 9th, y to the 8th, z to the 4th. That's a 3. Okay, come back here and we say, okay, 3 goes into 6 2 times, so this becomes 2 squared. Pull it out, and there's nothing left, nothing remaining. Let's go ahead and write our cube. Well, 3, this is 5 to the first. 3 doesn't go into the first evenly, so the 5 has to stay underneath. 3 goes into 9 3 times, so this is x to the third. 3 times 3 is 9, so there's no remaining. So you can think of this as x to the 0 under here if you want. But x to the 0, anything raised to the 0 power is 1, so we won't even write that underneath there. 3, I lost my... 3 goes into 8. See, 3 goes into 8. See, would be 2 times. Would be 6 with 2 remaining. So we can pull out a y squared. And we have 2 remaining, so it would be y squared underneath there. Then we look at our z component, and 3 will go into 4 one time, so we can pull out 1z. And then there's 1 left, so you can say as 3 goes into 4 one time, and 3, so there's 1 left, so there will be 1z left underneath. So the solution there would be 2 squared, okay, which would be 4 x cubed y squared z times the cube root of 5y squared z.